right? So as I said, today we will discuss how to express the other quantities like velocity, speed, acceleration, and such things when object is moving in 2 dimensions. Okay, when motion is happening in a plane. Okay. One of you quickly tell me, how do we write the position vector in 2 dimensions when object is moving in a plane? Suppose the particle is at x comma y. We know its x coordinate and y coordinate. How do we write its position vector? If the particle is at x comma y, how do you write its position vector?
Sir, xi plus yj.
Xi cap plus yj cap, correct. Fine. So this is basically its position with respect to origin. Okay. When we don't specify any separate reference, it is understood that the position is written with respect to origin. Fine. I cap, as we know, is the unit vector along the positive x-axis. Okay. So I cap is fixed. And j cap also. I cap and j cap are standard vectors which everybody knows. Okay. And we are using them. So these two will be treated like constants. I cap is a constant. J cap is also a constant. Okay. Now imagine the object moving on the plane. Let's say the object is initially here having some x coordinate x1 and y coordinate y1. And let's say it travels along a random path and reaches somewhere here from A to B where it has coordinates x2, y2. So basically as the object moves in a plane, its coordinates will keep changing. Okay, the x coordinate and y coordinate will keep changing. Means the x component of the position vector, okay, see this part is the x component of position vector along x-axis. This part is the y component, that is its component along the y-axis. When x coordinate and y coordinate change, then the x component of the position vector and y component of the position vector will change. Okay. One of you quickly tell me the definition of velocity, basic definition of velocity. Or a basic formula for velocity. So it should not take this long just to tell one definition.
Sir, displacement by time.
No, that is average velocity.
Rate of change of displacement in particular direction.
Okay, see, you don't have to say particular direction. When you take rate of change of displacement, no direction will get included in that. Okay, so rate of change of displacement with respect to time, you must say. Or you can also say, you can also say the actual definition is rate of change of position with respect to time. Mathematically, these two are the same. Okay, but actual definition is the rate of change of position with respect to time. Okay. And how do we write this mathematically? How do we calculate rate of change mathematically? Vanilla, can you tell? Generally, rate of change of y with respect to x or r with respect to t, how is it calculated?
Displacement by time, sir.
No. Generally, how do we calculate rate of change of a quantity y with respect to another quantity x? That is my question. Anyone? How do we calculate velocity? Displacement by time gives you average velocity. That is okay. But average velocity is not the only velocity that we have. No, we had discussed this while moving in a vehicle. What you see on the speedometer is not average speed. It is instantaneous speed. At that moment, how fast the vehicle is moving is what the speedometer shows. How is instantaneous velocity calculated?
Sir, ds by dt.
dr by dt. Okay. See, rate of change means derivative. Okay. Average rate becomes delta. Instantaneous rate will be dr by dt. Average rate of change will be delta r by delta t. That is displacement by time. Okay. Anyway, to get velocity, you need to differentiate position with respect to time. Okay. Now observe this. Slightly mathematical stuff, but I'll explain the meaning, then it will become clear. Now we have written position vector r as xi cap plus yj cap. Based on the coordinates, we can tell the position vector. And we know that by definition, velocity is derivative of position with respect to time. So you need to differentiate xi cap plus yj cap. Okay. How do you differentiate the sum of two functions? You differentiate them separately. Derivative of xi cap plus the derivative of yj cap with respect to time. Okay. Now one of you tell me, how do you differentiate 2x cube? Derivative of 2x cube.
We keep the constant outside and then
Good,
derivative
good. That is exactly what I was looking for. You keep the constant aside and differentiate the variable part, right? Similarly here, see, we know I cap is a standard unit vector along the x-axis. It is never going to change. Okay, I cap is a standard reference that we all use. It's a fixed value. It has a magnitude of 1 unit. Its magnitude is fixed, 1 unit. Its direction is also fixed, positive x direction. So I cap and also j cap, they are constants. They are never going to change. So we'll put them outside the derivative. So then this becomes rate of change of x coordinate I cap plus rate of change of y coordinate j cap. So that is the velocity vector. And this has a meaning associated with it. Let us understand that. We got the velocity in terms of the components. Obviously, when an object is moving in a plane, it will be moving along the x direction. It will also be moving along the y direction. So there will be an x component of velocity. There will also be a y component of velocity. Okay, so these are the components. As you can clearly see, this part is the x component of velocity, and this part is the y component of velocity. Okay, so you can also write this as x component Vx I cap, that means velocity in the x direction, and Vy j cap, velocity in the y direction. Okay. And understand this, velocity in the x direction changes the x coordinate of the object, and velocity in the y direction changes the y coordinate of the object. Okay. Let me adjust this. We'll solve problems, you'll understand this clearly. X component of velocity changes x coordinate, y component of velocity changes the y coordinate. Okay. What do we mean by this? Suppose there's an object. Let's say there is some object moving, say like this, with a velocity of 20 meters per second at an angle, say 37 degrees. Okay. Aishwarya, tell me the x component of this vector.
So 16 I cap.
Good. 20 cos 37 becomes 16. So that's the velocity in the x direction. Vx vector becomes 16 I cap. Correct. Vanilla, tell me the y component of its velocity.
Twenty cos 53, sir. How much? Cos 53 is 3 by 5.
How much? Cos 53 is 3 by 5. 3 by 5. 3 by 5 is 3. 3 by 5 is 3 by 5. 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 3
12 j cap.
12 j cap, correct. So it has a component 16 in one direction, 12 in the other direction. Okay. The actual velocity is 20 meters per second. That means in 1 second, it will cover 20 meters in that direction. Now, let's say by covering 20 meters, the particle goes from this position, let's call this position as A, to some new position B. Assume B is somewhere here, 20 meters away from A. So the total distance between A and B is 20 meters. But when the object goes from A to B, it will have some, okay, let's say its x coordinates here are x comma y or x1, y1. And at B, the coordinates are x2, y2. Okay. So there is a change in x coordinate. There is also a change in y coordinate, right? The change in x coordinate is this much. This is the change in its x coordinate. And the change in y coordinate is this much. Delta y. Okay. And this delta x will be 16 units. If the total displacement is 20, then the x component of displacement will be 16 units per second. In 1 second. In 1 second only, no, it went from A to B. We took AB distance as 20 meters. Okay. If AB distance is 20 meters, let's call this point as C. AC distance will be 16 meters, and that will also be covered in 1 second only. Okay. So 16 meters in 1 second means the velocity in that direction is 16 meters per second. And that is what we got the component as. Okay. So body is not actually moving in the x direction. It's moving in some other direction. But along the x direction, it will cover 16 meters per second. That is what it means. That is what the component of velocity means. Okay. And the x component of velocity dictates what happens along the x-axis, how fast the object moves along the x-axis. Y component of velocity dictates how fast the object moves along the y-axis. Okay. So we can write velocity as x component I cap plus y component j cap. And how do you get this? X component of velocity is how quickly the x coordinate changes, and y component of velocity is how quickly the y coordinate changes. So rate of change of x coordinate is the x component of the velocity, and rate of change of y coordinate is the y component of the velocity. That's all. Similarly, acceleration. One of you quickly tell me, how is acceleration defined? How is acceleration defined?
Rate of change of velocity with respect to time, sir.
Correct. How do we write it mathematically? Formula. Rate of change of velocity with respect to time. How is that?
dv by dt, sir.
Correct. dv by dt. So to get acceleration, we need to differentiate the velocity function, which is vx I cap plus vy j cap. Okay. Pawan Ashish is saying double differentiation. That is also correct. We'll come to that. Okay. What he means is, if you differentiate position, you will get velocity. So velocity is the first derivative of position. If you differentiate velocity, you will get acceleration. No, means you have to differentiate the first derivative of position. Means you have to make it the double derivative. Anyway, let's not make it that complicated for now. Let it be like this. You differentiate velocity, you get acceleration, right? So you can split this into two components again. As I said, I cap, j cap are constants, put them aside. It becomes rate of change of x component of velocity, I cap, plus rate of change of y component of velocity, j cap. And this can effectively be written as x component of acceleration, I cap, plus y component of acceleration, j cap. So Just like x component of velocity makes the object move along the x-axis, the x component of acceleration changes velocity along the x-axis. Similarly, the y component of acceleration changes velocity along the y-axis. So basically how we are going to deal with motion in a plane is, we are going to split it into two separate motions, one along the x-axis, one along the y-axis. X component of velocity, x component of acceleration will make the object move along the x-axis, or will dictate how the object moves along the x-axis. And y component of velocity, y component of acceleration dictate how the object moves along the y-axis. And finally, we'll combine these two and find out where the object finally gets to or goes. Okay, so motion in a plane is not difficult. It is just two one-dimensional motions. That's all. How to split it into two separate 1D motions is what we are learning now. Fine. So all the x components are related, all the y components are related. Put them together, you can visualize the overall motion of the object. Okay. Let's try one question. Same equations of kinematics and all also will be valid. Can any of you tell me the condition to apply equations of kinematics? When are they applicable?
So the acceleration is constant.
Good. Acceleration is constant. Now, acceleration is a vector quantity. In this case, in motion in a plane, if you want to check whether acceleration is constant or not, you have to look at both its components. Okay. So the x component of acceleration must be constant, y component must be constant. Then you can apply equations of kinematics in both directions. Suppose only x component is constant, then you can apply equations of kinematics only along x-axis. If only y component of acceleration is constant, then you can apply only along the y-axis. Okay. Anyway, let us try some questions. Let's say the object is initially at some coordinates 2, 4. Assume its initial velocity is 0. When we say 0, it is 0 I cap plus 0 j cap. No x component, no y component. It was not moving initially. And assume it has an acceleration of 2 I cap plus 4 j cap meters per second square. So we know the initial velocity, we know the acceleration. I want you to calculate its velocity at t is equal to, say, 3 seconds. Then speed, v without a bar indicates speed. Okay, speed at t is equal to 3 seconds. And then calculate displacement in 3 seconds. Okay, try this, all of you. First tell me, Nishita, this acceleration 2 I cap plus 4 j cap, is this a constant acceleration or not? And how are you deciding that? Okay, someone else. Is this acceleration constant or not, and how to decide? See, if it is not constant, no, then it should depend on some other variable like time or position or velocity or anything like that. Okay, what I mean is, suppose you have an acceleration like this, a is equal to 2t I cap. Then from time to time, this acceleration is going to change. Then it becomes non-constant variable. Suppose you have acceleration is equal to 2x I cap. That means from position to position, the acceleration will change. Then also it is not constant, it is not uniform. Okay. So you look at the given expression, sorry, 2 I cap plus 4 j cap. There is no time or velocity or position or anything involved in it. Okay, that means the acceleration is always 2 I cap plus 4 j cap, no matter where the object is, no matter how much time it takes. Okay, therefore it is constant acceleration. Carefully apply equations of kinematics now. Solve this, all of you. You just have to add vectors in 2 dimensions now. Try. Can one of you tell me which equation of kinematics helps you calculate velocity after some time? Which equation will you use for the first part?
Sir, V is equal to U plus AT.
Correct. V vector is U vector plus A vector multiplied with T. Try this. Substitute the given values. To answer these three questions, it doesn't matter where the object initially was. Okay, so I'm covering that part. Try. Aishwarya, any answer?
Sir, is it root 180?
You took the magnitude also. Okay, I didn't ask you to take the magnitude. Anyway, but before taking the magnitude, what was the vector you got?
6 I cap plus 12 j cap.
That's all. U is 0. You don't have to consider that at all. Simply A into T. A is 2I cap plus 4j cap. Multiply that with time 3. Time is a scalar. It's like a number only. When you multiply a vector with a number, no, its components get multiplied by that number. So effectively it becomes 6I cap plus 8j cap meters per second. Okay. And see, you should not say the magnitude when you're asked velocity, because velocity is something which comes with a direction. You can't simply tell the magnitude and call it velocity. So you can just leave it like this. This vector itself is the velocity vector. 6I cap plus 8j cap. Okay, 12, sorry, 12. 4 threes. Okay, this vector itself is the velocity vector after 3 seconds. Okay. Yusuf, can you tell how to calculate speed? Do we have any equations of kinematics for speed? No response. Vanilla,
Sir,
you.
sir.
Tell.
So what are the questions, sir? So speed,
How to calculate speed
so
is the
distance
question.
by time.
We don't know the distance in this case. And we'll see, those are 6th class definitions.
Yes.
Speed is rate of change of distance covered with respect to time. It is ds by dt now. Okay. And we don't have an equation for distance. So you can't tell how much distance it covers in 3 seconds. Okay. We don't know the distance yet. And also distance by time gives you average speed. We want instantaneous speed. At that moment, we want the speed. So what can be done? I told you this many times in motion in a straight line also. We don't have equations for distance and speed. Okay. All the equations of kinematics, they involve velocities, displacements, accelerations. Okay. They don't directly give you the speeds and distances. But how to find out speed in case you want to calculate? Anyone?
The instantaneous speed is magnitude of instantaneous velocity.
Very good. Very good. Okay. So we calculate velocity using equations of kinematics or whatever procedures we have, and then take its magnitude. Speed is the magnitude of instantaneous velocity. And we know instantaneous velocity here, 6I cap plus 12 j cap. We have to take its magnitude. Okay, Yusuf, tell me how to calculate the magnitude of a vector which is expressed like this. Like suppose the vector is xi cap plus yj cap. How do you calculate its magnitude? Okay, see, solve those worksheets. You have to get used to all this. Aishwarya, can you tell how to calculate magnitude of a vector?
Sir, root of x square plus y square.
Root of x component square plus y component square. Okay, I'm sure that is what you must have done. So it becomes root of 6 square plus 12 square. 12 square 144, 6 square 36. Add them, it becomes root 180 meters per second. You can simplify that also, but let us leave it here. So remember, speed is calculated from velocity because here you don't know distance. Okay, you are not given the distance equation. It's difficult to derive. You can do it, but it's difficult. So it's easier this way. Get velocity, take its magnitude, that becomes the instantaneous speed. Okay. Next, displacement. Pawan, which equation helps us calculate the displacement in a certain amount of time?
Sir, S is equal to GT plus half L square.
Correct. S vector is u vector into t plus half a vector into t square. So how much will that make the displacement in this case? U is 0, so ut will be 0. Half a vector is 2I cap plus 4j cap. T is 3 seconds, t square would be 9. Okay, you can cancel this 1, 2. So 1I cap plus 2j cap into 9 effectively becomes 9I cap plus 18j cap meters. That is the displacement. Okay, hope this is clear to all of you. We have directly applied the equations of kinematics and it's reasonable. It's applicable here because the acceleration is constant. Now see, when we discussed how to calculate velocity in 2 dimensions, acceleration in 2 dimensions, I told you the x component of velocity and acceleration dictate the motion along the x-axis. Okay, let us verify that now. Now we got the total displacement. That's fine. We got both components of the displacement at once. Okay, we got the x component of displacement and we also got the y component of displacement. Because we used both components of all the vectors, we got both components of displacement. That's fine. But you could have done something like this also. Suppose you want displacement only in the x direction. You can write it as initial velocity in the x direction into time plus half acceleration in the x direction into t square. Just take only the x components of all the vectors. You will get the x component of the required vector. It works that way also. Let us check. Initial velocity completely was 0. So this part is 0 plus half. Now you all look at the vector and tell me how much is the x component of acceleration? Only the x component of acceleration. How much is it?
2I cap, sir.
2I cap. Okay, so 2 t square. T square is 9. So these two will get cancelled. You get it as 9I cap, which is what we got here. Obviously, okay. I cap will not disturb j cap. J cap will not disturb I cap. So x components will be calculated separately. Y components will be calculated separately. Even if you do it together, no, they are independent of each other. When we calculated displacement using that equation directly, we got both x component and y component of displacement at once. Okay. But if you observe the calculation, all the x components got put together and became 9I cap, and all the y components got put together and became 18j cap. You could have calculated them separately also. Okay, even with velocity, if you want only the y component of velocity, let's say Vy. We know V is equal to u plus at, no? If you only want y component, you only take y components of the other vectors also. Okay, V is equal to u plus at. Now initial velocity's y component is 0. Acceleration's y component was 4j cap. So 4j cap into time was 3 seconds. So that becomes 12j cap meters per second. And that is what we had gotten before also. Y component of velocity is 12j cap. So remember, so this is what I was saying. It's quite easy to describe motion in a plane in 2 dimensions. You just split it into 2 separate 1-dimensional motions. That's all. And you finally put them together. Okay. Like you put the x component and y component together, you will get the total vector, overall displacement, overall velocity, and such things. Okay. But remember, you can comfortably take only the x components and tell what is happening along the x-axis. Take only the y components and tell what is happening along the y-axis. Okay. Let's try another question. Suppose the position of an object varies with time like this. 2t square I cap plus 4t j cap. Means from time to time, based on the time, the position changes. Okay, let it change. Now, what I want you all to do is, first thing, derive its velocity as a function of time. You know, you have to differentiate position to get velocity, so do that. Then derive its acceleration as a function of time. Then, okay, solve these two first. Okay, any answer for velocity as a function of time? Okay, Pawan, your answers are correct only. Yusuf, tell me, what is the derivative of 2t square with respect to time? Everyone seems to be busy today. You all are watching match on the other side or what? What is the derivative of 2t square with respect to time? Okay, some issue with your mic. Let it be, leave it. Vanilla, you tell me. Expression for velocity, or at least the derivative of the first part.
4t I cap plus 4 j cap, sir.
That's all. We're differentiating with respect to time, so it becomes 4t I cap plus 4 j cap. Okay. Next, Aishwarya, acceleration.
So 4 I cap.
That's all. Now see, observe the velocity vector, all of you. This is the x component of velocity, right? And it changes from time to time. Okay, this is a variable. And if velocity is changing, there is acceleration. Now the x component of velocity is varying from time to time. That's why there is acceleration in the x direction. Makes sense. Observe the y component of velocity. Y component of velocity is constant. It doesn't have t or anything in it. Okay, it doesn't depend on any term, any other variable. Y component of velocity is constant. When an object's velocity is constant, it means it is not accelerating. So that is why we got 0 y component of acceleration. Okay, if you observe, acceleration only had the x component, it didn't have the y component. Okay, that is what it means. The y component of velocity is constant. That's why there's no acceleration in the y direction. Okay, right. Next, speed at 1 second. Nishita, can you answer? Nishita is not active today. Anyway, Pawan, how did you calculate speed?
Sir, 40 square plus 4 square.
Repeat.
40 square plus 4 square.
Okay, you should not say 4t square. You should say 40 whole square. Okay. Anyway, I understand what you did, but the correct way to read it also will be 40 whole square. Okay, you should not say 40 square. Okay, so he used speed is magnitude of velocity. So root of x component of velocity squared plus y component of velocity squared, and you substitute t as 1. Okay, so root of 16 plus 16, root 32. Okay, you can write it as 4 root 2. 4 root 2 only, no? Huh. Okay. Another question for all of you. We know this particle's velocity, acceleration and all. So think and answer. Based on which vector? Okay. Position or velocity or acceleration. Based on which vector can you tell the direction in which the object is moving at a particular instant? Which vector can give you the actual direction of motion of the object at that particular instant?
Velocity.
Good, good. That is correct. See, simply by knowing the position of the object, you can't tell which way it is going. Like if I tell you that the object is at 1,5, can you tell which way it is going? No, you cannot. Okay. So position vector cannot tell you the direction of motion of an object. Velocity. See, velocity is rate of change of position with respect to time. Now, by definition, V is dr by dt. Dr is nothing but final position minus initial position divided by dt. Of course, it's a small change only, let it be. Now, final position minus initial position is basically a small displacement, right? And displacement is from initial to final, so it can indicate which way the object is moving. Fine. Velocity indirectly involves a small displacement. So that way you can clearly tell which way the object is going. So remember always, whether it is 1 dimension, 2 dimension or 3-dimensional motion also, velocity is what tells you which way the object goes. Okay. Even acceleration cannot tell you which way the object is moving at that particular instant. It can tell you what will happen to it later on, but at that moment how it is moving, it cannot tell. For example, we discussed motion under gravity, 1-dimensional motion under gravity, ball going up and coming down. Okay. Now gravity is always downwards, but the ball is sometimes going up, sometimes coming down. So simply based on the fact that gravity is downwards, you can't tell whether the ball is going up or coming down. Okay, it depends on the direction of its velocity. If it has upward velocity, ball is going up. If it has downward velocity, ball is going down. Okay, so always remember, velocity is what tells you the exact direction of motion of the object. Okay, now here we got the velocity function as 4t I cap plus 4 j cap. Okay. Clearly, it's a variable velocity. The x component of velocity keeps on changing. Y component remains constant. Let it be. Now, what I want you to find out is angle made by the velocity vector with the x-axis at t is equal to 2 seconds. Okay, a vector will have a particular direction, no? Means it must be making some angle with the x-axis. So at t equal to 2 seconds, you should find out how much angle it makes with the x-axis. Can one of you tell me how to find out, like what are the steps to be taken to find out the angle made by a vector with the x-axis or the y-axis? X-axis only you tell first. These questions were also there in the worksheet.
Tan theta equals to y component by x
Good,
component. sir.
good. You should get the components. You have to visualize the components. In fact, as I said, don't solve it simply like don't only solve it mathematically. Imagine what is happening. Okay, so follow those steps, all of you. We need the angle made by the velocity vector with the x-axis at 2 seconds, no? So first thing to do, write the velocity vector at 2 seconds. Next thing to do, draw the components. Draw the components and the arrow also. Then finally you find out the angle, calculate the angle. Try this, all of you. Okay, don't even remember that formula tan theta is equal to y component by x component. Remember this idea that if you know the components, you can tell the angles with x-axis or with y-axis. That's the idea. Based on components, you can tell angles. Okay, components and trigonometry. Yeah. Any answer, anyone? Even if you don't get the exact angle, at least tell me tan theta value or cos theta value or sin theta value, whichever you were able to calculate. Any answer? Okay, first tell me, what is the velocity vector at 2 seconds?
8 a cap plus 4 j caps.
You just have to substitute t is 2 there. It becomes 8 I cap plus 4 j cap. Meters per second. Okay. So we got the x component and the y component. You draw the components and clearly the velocity vector is the sum of these two components. I told you when converting from component form to the diagram, okay, draw the components in order. Means one component followed by the other component such that the actual vector and the components form a triangle. Okay, we'll do all that, you'll understand. Of course, we had done that before also. Aishwarya, tell me, in which direction does 8 I cap point?
Positive x direction.
Positive x direction, correct. 8 units, so I'll take it roughly like this. Let this be the x component of velocity 8 I cap. Then 4j cap points in the positive y direction, and I will draw the y component such that its tail is at the head of the x component. So I'll draw the components like this. Just a moment, let me adjust them. Right. So 8 I cap is one component, 4j cap. Okay, 4j cap should be half of 8, no? So I'll adjust that length. Anyway, these are rough diagrams only. Still, let's be as correct as possible. Okay. So 4j cap. Now the given velocity, or the velocity that we found out, is the sum of these two vectors. Now these two vectors are in order. When two vectors are in order, their resultant, means 8I cap plus 4j cap, will be the closing side of the triangle taken in reverse order. Okay, from the free tail to the free head. So the velocity vector effectively becomes this. So object is moving like this. How much is it? 8I cap plus 4j cap. You can tell its magnitude also if you want. Root of 8 square plus 4 square, root 64, root 80. Okay, so this vector's length is root 80 units. Square root 80, if you remove 16 from it, 16 fives, no? So this becomes 4 root 5 meters per second. Okay. Now I asked you to, the third part, calculate the angle that the velocity makes with the x-axis. Now you can visualize the x-axis. It is to the right. This is the x direction. So this angle is what we want. Name it whatever you want, theta, alpha, whatever. So as I said, when you visualize components and the original vector, no, you will clearly see the right angle triangle. Because we are taking components in perpendicular directions. They are called orthogonal components. Definitely they will form a right angle here. Okay. Then as I said, using any one of the trigonometric ratios, you can express that angle. Suppose you want tan alpha. Okay. Pawan, tell me, how do you calculate tan alpha in this case? What is the length of the opposite side?
Sir, 4j.
No, you should not say
4.
j. Okay. 4 units. Length of the adjacent side?
Sir, 8.
8. So tan alpha becomes 4 by 8. That is 1 by 2. So listen, some of you may be new to this, but anyway, you all will be writing objective exams. No, so they may give you tan alpha in the options, or they may just say alpha in, they may ask you alpha value in the options. Then you should send tan to that side. Aishwarya, tell me, how do you write alpha now? How do you send tan to the other side?
So tan inverse of 1 by 2.
Correct. Tan inverse of 1 by 2. That's all. So that's how you write it. But see, it's not necessary that they expect you to calculate only the tan value. You know opposite, you know adjacent, you know the hypotenuse also. So you can calculate sine, you can even calculate cos. Okay, so the options may be in terms of sine inverse, cos inverse. So you should not get confused there. So generally, not just this question, I'm telling you, when attempting an objective exam, no, you should read the question, you should see the options once, and then start solving the question. Okay, you'll understand what kind of answer they are expecting. Okay, so if you simply sit calculating tan alpha here, and you see that the options are in terms of cos inverse, then this part of the calculation would be waste. Okay, so that will waste time. You should always read the options once, then start solving the problem. Okay, so tell me, Vanilla, you tell me, how much is sine alpha in this case?
One by root 5, sir.
Opposite by hypotenuse. Opposite is 4. Hypotenuse is 4 root 5. Correct. 1 by root 5. So you can write alpha. The same angle alpha can be expressed as sine inverse of 1 by root 5. Okay. This is correct. This is also correct. Okay. Next. You can even calculate cos alpha. Adjacent by hypotenuse. Adjacent side to the angle alpha is 8. Hypotenuse is 4 root 5. 4 cancels 8 2 times. So 2 by root 5. So alpha is cos inverse 2 by root 5. This is also a correct answer. Okay, and they'll give options like this only. They won't expect you to tell alpha value in degrees. Okay, obviously you don't need to know you don't need to know sine, cos, tan values of every angle. Okay? So they won't expect the answer in degrees. They'll expect it this way. Okay. Same question. Velocity is 4t I cap plus 4j cap, right? Now I want you to find out. See, imagine what happens. Suppose t is 0 here. When t is 0, the velocity's x component becomes 0, only y component is there. Means at t equal to 0, the object is moving this way. Velocity is in y direction, means object moves in the y direction. Next, at t equal to 2 seconds, we just found out. 8 I cap plus 4j cap. No, you can see the direction here, 8 I cap plus 4j cap. So by 2 seconds, the object will be moving somewhat like this. Next, let's say at some 10 seconds. If you put t as 10, the x component becomes 40, y component remains 4. X component 40 and y component only 4. Means it will tilt more towards the right side. Okay, so we can kind of imagine how this object is moving. Initially it was moving this way. Later it turns and turns and turns to the right. So it's actually going like this. Okay, it's following that curved path, motion in a plane, two-dimensional motion. Okay. Anyway, so this is what happens to the object, right? Its velocity vector keeps on tilting to the right. Initially, its velocity vector was in the y direction, but it tilts towards the x direction as time passes. Okay. So at some time, the velocity vector should be making 45 degrees with the x-axis. Okay. Initially, it was making 90 degrees with the x-axis. This is the x-axis. It was moving this way. So initially, it was making 90 degrees. But as the object turns, turns, and turns, okay, the angle made by the velocity vector keeps changing. It keeps tilting to the x direction. So at some moment, at some time, the velocity would have definitely made 45 degrees with the x-axis. Okay. Think of a way to calculate the time when the velocity makes 45 degrees. Try this, all of you. That's the question. Okay. At what time does the velocity make 45 degree with x-axis? Think of an idea to calculate this. Okay. I got two answers as 1 second. 1 second is correct. But can you tell the idea? Vanilla, how did you arrive at that answer?
Sir, tan 45 equal to 4 by 40, sir.
Good, good, very good. You are making very good use of that formula. Fine. See, we know the angle made with the x-axis, no? So she is directly using that formula. This formula was there in your worksheet. Tan alpha is y component divided by x component. Good, no problem. Pawan, what did you do?
Sir, same, sir.
Okay, okay. So we want the angle to be 45 degrees. Should be equal to y component of velocity is always 4. X component is 4t. And we know tan 45 is 1. So 1 is equal to 4 divided by 4t. You get t as 1 second. Good. Not an issue. You can solve it this way. Okay. Others, Aishwarya, Nishita, Yusuf, is the method clear?
Yes, sir.
Okay, like you can look at this diagram. Let's say alpha is the angle made with the x-axis. Tan alpha, opposite of this angle is the y component. Okay. And adjacent to this angle is the x component. That's why we say tan alpha is y component by x component. Okay. Right. That's fine. Okay, this will always work, not an issue. But see, as I said, don't make things purely mathematical. Visualize. We want the velocity to make 45 degrees with the x-axis, no? Imagine that happening. So consider a velocity vector like this. Not just in this question, I think I told you this before also. In every physics question, they'll ask you about when something happens, where something happens. Okay, so imagine that something happening. So we want the velocity vector to make 45 degrees with the x-axis, then obviously it will make 45 degrees with the y-axis also. Because total angle between x and y is 90. So that part 45, this part will also be 45. Now see, a vector makes the same angle with x-axis and y-axis. That means its x component will be equal to its y component. If the angles are same, the components will be same. Okay. So velocity's x component should become equal to velocity's y component. That way also you could have answered this. We know x component of velocity in this question is 4t. Y component is 4. From there also you get t is equal to 1. Okay. So this is based on visualization and this is important. Okay, cool. Now let us discuss one idea. This will help us visualize motion in 2 dimensions more easily. Tell me this from whatever you understood based on what we discussed till now. Suppose an object is moving in a particular direction. Moving in a particular direction means it has velocity in that direction. So let's say an object has velocity in some direction like this. If it gets acceleration in the same direction, see, how do you give acceleration to an object? You push it in that direction, okay? You apply a force, you give acceleration. You know F net equal to ma. So suppose it accelerates in the same direction as its velocity. What is going to happen to the object? An object moving in a particular direction is given a push in the same direction. What will happen to the object?
It will move faster, sir.
Correct. Its speed will increase. What about direction? Will it continue in the same direction or not? If you push it in the direction in which it is moving, will it continue in the same direction or will it change direction?
It will move in the same direction, sir.
Obviously, it will move in the same direction. Okay. Something which has been moving one way is given a push in the same direction, then it will move faster in that direction. That's all. Okay. We can prove this mathematically also. Anyway, we'll do that. So if velocity and acceleration are in the same direction, the object will continue in the same direction, but it will move faster. So it effectively moves on a straight line, a tilted straight line, you can say, which is not exactly along the x-axis or y-axis, but it's a straight line. And we had discussed this in motion in a straight line also. If velocity, acceleration are in same direction, object will continue in that direction. We know that. Okay. If velocity is this way, but acceleration is exactly opposite to it. Okay. Someone other than Vanilla, tell me what will happen.
సార్ కొంచెం దూరం వరకు వెళ్ళి స్టాప్ అయిపోతుంది సార్.
అంతేనా? తర్వాత కదలదా?
సార్ మళ్ళీ బ్యాక్ కూడా వస్తుంది.
So same as we learnt in motion in a straight line, Yusuf is saying it undergoes retardation. Correct. Since acceleration is opposite to velocity, it slows down first. Moving in the same direction, it will slow down. The magnitude of velocity will decrease. It stops somewhere and then returns because the acceleration will continue. If the acceleration continues, it will come back along the same straight line. Let us verify this. Okay. There will be some mathematics involved in this, but you need to know how to do all this. Obviously, you all want to become engineers. Okay. Some of you want to become doctors also, but still, you should be able to use this much mathematics. So yeah, first, okay, we'll check this case directly, second case. So we need to imagine a situation where velocity and acceleration are opposite, and we have to take two vectors like that. Let us do that. Let me draw the coordinate axis. We'll have to put our vectors knowledge into application here. Let's take 30-degree angle. 30 or 37-degree angle, let us take. Numbers will be convenient if you take 3753. So we need to consider a velocity vector like this, which makes 37 degrees with the x-axis. And then we need to consider an acceleration vector, which is exactly opposite to it. So somewhat like this. If velocity makes 37 degrees on that side, then acceleration will make 37 degrees on this side because it is exactly opposite. Fine. Vanilla, tell me, how much initial velocity shall we take? Magnitude. Tell some number.
0, sir.
0 na, matalle. That will be a good example only. But see, we want to check the situation where velocity is there and acceleration is opposite to it. Okay. With 0 velocity, you can't say acceleration is opposite to it. We had talked about this vector before. A vector of 0 magnitude is called a null vector. You can't tell the direction of a null vector. And if you can't tell the direction of a null vector, you can't say that acceleration is opposite to its velocity. Okay. So make it non-zero.
20 meters per second.
Okay, 20. Fine. Aishwarya, tell me the components of that vector now. Express it in terms of I cap, j cap.
So 12 I cap and 16 J cap.
No. With x-axis, it is making 37 degrees. So x component will be 20 cos 37. Cos 37 is 4 by 5. It becomes 16 I cap plus 12 j cap. Meters per second. Okay. Fine. Pawan, tell me some numerical value for acceleration. ఎంత తీసుకున్నాం?
10 meter per second.
10 meter per second square you want to take. Okay. Reasonable. Make it a vector now. Tell me its components.
Sir, 8 I cap plus 6j cap minus 6j cap.
8 I cap minus 6 j cap will be like this. But I don't think the acceleration is like that, so your components are wrong.
Oh, sorry, minus 8 I cap.
Okay. It has negative x component and negative y component. And this will be 8 units, this will be 6 units. So minus 8 I cap minus 6 j cap. Meters per second square. Okay. So now we have imagined a situation, or we have considered a velocity and an acceleration which are exactly opposite to each other. What we now want to do is check whether the velocity, we want to check what happens to the velocity. Okay. And according to our imagination, we believe it should slow down, stop somewhere, and then come back. Okay. So what we will do first is we'll find out when it stops. That's the first time that we'll find out. Okay. We have considered constant acceleration. You can use equations of kinematics. So do this, all of you. What is the time when velocity becomes 0? You decide which equation to use. Use it. Tell me the time. You can just unmute and tell your answer once you're done. Why is it taking so long?
2 seconds, sir.
2 seconds. Okay. Which equation do you use to find out the time when velocity becomes 0?
V equal to U plus A.
V equal to U plus AT. We want velocity to become 0 is equal to U is 16 I cap plus 12 j cap plus acceleration is minus 8 I cap minus 6 j cap multiplied with t. Okay. Just follow this, all of you. I know you are new to applying equations of kinematics in 2 dimensions, but this is how it is done. Just write the u vector as it is plus a vector as it is multiplied with time. Okay, time is what we need to calculate. Now separate the x components and y components. So you get 0 is equal to 16 minus 8t I cap, because from u you get 16 I cap, from acceleration you get minus 8t I cap. They're being added, so 16 minus 8t I cap plus in the y direction 12 minus 60 j cap. Now we want the velocity to be 0, means the x component should be 0, y component also should be 0. When will 16 minus 8t become 0? That happens at t equal to 2 seconds. And when will 12 minus 60 become 0? That also happens at t equal to 2 seconds. Means at t equal to 2 seconds, both components of velocity become 0, the object stops. Okay. And as expected, the object is stopping somewhere. Okay. At 2 seconds, it stops. Fine. So it takes 2 seconds to go from here to here. So what we are now going to do is, we'll find out its velocity at 1 second. We'll check whether it is in the same direction as the original velocity or not. And we'll also check its velocity at 3 seconds. Sometime after 2 actually. Let us use 3 seconds. And from what we expect, at 3 seconds, the velocity should be exactly opposite to the first velocity or initial velocity. So we are going to check this now. So you know the initial velocity, you know the acceleration. Do this, all of you. What is the velocity at 1 second? And what is the velocity at 3 seconds? Calculate them first, then we'll check the direction. Aishwarya, velocity at 1 second. Okay, Vanilla, your answers are correct only. Okay. Anyway, if you just substitute t as 1, you will see that the velocity at 1 second is 8 I cap plus 6 j cap meters per second. Okay. Let us check if this velocity at 1 second is in the same direction as initial velocity or not. Now, initial velocity was making 37 degrees, right? It had an x component of 16 units and a y component of 12 units. You can say tan 37 degrees is equal to 12 by 16. We know 3 by 4. And that is correct only. Okay. Now at 1 second, the components are 8 I cap and 6 j cap. Let us visualize that. At 1 second, 8 I cap would be like this. 6 j cap would be like this. So the velocity vector is this 8 I cap plus 6 j cap. Let's assume it makes some unknown angle alpha at 1 second. And we can write tan alpha is opposite by adjacent 6 by 8, that is 3 by 4. Okay. Now tan 37 is 3 by 4. Tan alpha is also 3 by 4, means alpha is same as 37. That means after 1 second also, it is going in that 37 degree direction itself. So correct. So what we have imagined is correct. Fine. So if acceleration is exactly opposite to velocity, it slows down and continues in the same direction for some time. You can even see that it has slowed down because initial velocity is 16 and 12. The components are 16 and 12. After 1 second, the components become 8 and 6. The components have become smaller. That means the original vector becomes smaller. Okay, so velocity's magnitude has decreased, direction remains the same. Up to 2 seconds, it remains the same. Okay. Aishwarya, did you calculate velocity at 3 seconds? No response. Okay. Pawan, you said velocity at 3 seconds is minus 8 I cap, minus 6 j cap. Okay, let us check. Minus 8 I cap at 3 seconds. This is minus 8 I cap. And minus 6 j cap would be downward like this. So minus 8 I cap, minus 6 j cap, the velocity is like this now. Okay. Let's call this angle as beta. And from this right angle triangle, we can see tan beta, opposite side is 6 units. You won't consider the minus sign, okay? Because we want the length. And adjacent side is 8. 6 by 8 is 3 by 4. And if tan of an angle is 3 by 4, we know the angle is 37 degrees. So at 3 seconds, the velocity is directed in the, the velocity makes 37 degrees with the negative x direction. This is negative x. Okay. Initially, how was the velocity? It was making 37 degrees this way. This is initial velocity, making 37 degrees. After 3 seconds, the velocity is like this, making 37 degrees. And you can see that these two are exactly opposite. So again, what we have imagined is correct. The object slows down, stops, and then returns with its velocity being exactly opposite to the initial velocity, means it returns along the same straight line. Okay. And you can easily check this also. if velocity and acceleration are in the same direction, you can see that it will become faster and faster, but continue to be in the same direction. Now tell me, either from this discussion or based on your everyday experience, how can we make an object deviate from the straight line on which it is moving? Now, if you push it in the same direction, it will continue in the same direction. If you push it opposite, it will slow down and come back, but it will stay on that straight line. How to make it go away from that straight line? Like how to make it take a turn? Let's consider these reference directions: east, north, west, and south. Let's say there is an object moving towards east. Okay, so basically it's moving on that east-west line, right? How do you make it go away from that line? That is my question. How should you push it?
Or opposite to the force.
What force?
అంటే అటు యూ ఈస్ట్ వైపు డైరెక్షన్ కదా సార్
Velocity is in
దానికి
eastward.
ఆపోజిట్ సైడ్
If you give it opposite, then it will slow down and stop and come back on that same straight line, no? మళ్ళీ ఇట్లా వస్తుంది కదా వెనక్కి. We want to make it go away from this line, out of this line. How can that be done?
So we have to push it with more force than it is moving.
In which direction should you push it? That is the question.
In opposite direction.
If you push it in opposite direction, whether it is with less force or more force, if you push it exactly opposite, it will slow down, stop, and come back along the same straight line. It won't go out of that straight line. We want to make it go out of that straight line. Then how should you push it?
సార్ అంటే సౌత్ డైరెక్షన్ నుంచి నార్త్ వైపు పోస్ట్ పెడితే
From south towards north or some other direction. Any direction other than same or opposite. If you apply force in the same direction or the exact opposite direction, the object will stay on that line only. But if you apply force in any other direction, okay, whether like this or like this or like this, infinite other possibilities are there. What took you so long to think of these possibilities? In any of these cases, the object will deviate from the line on which it was moving. Okay, then it becomes two-dimensional motion. Okay, so let us discuss some technical aspects, like mathematical aspects of this. Basically, you apply force in some direction means you give acceleration in that direction. So let's talk in terms of acceleration now. So if velocity and acceleration are not along the same line, the object deviates, or you can say turns. Then the motion becomes two-dimensional or three-dimensional. Okay. Now let us imagine velocity and acceleration like this. Let this be the velocity. Just as an example, I'm taking it towards right. Okay. And let's take acceleration in some other direction, like this. If you want, you can verify this also. Like, you take a very light ball, like a plastic ball, okay, very light plastic ball. What you do is, you switch on a fan, not ceiling fan, horizontal one, table fan, okay, or you can simply blow air also horizontally. So you switch on the fan. So what I'm saying is something like this. Let's say this is the fan blowing wind this way. If wind is blowing like that, it will exert a force on the ball in that direction. So what you do is, you throw a ball like this. You throw the ball like this. Means its velocity will be in this direction, but its acceleration will be this way. Acceleration will be to the left, like in the direction in which the wind is blowing. And you will see that the ball will deviate. It won't continue on that straight line. That is what, I mean, if you want to visualize it, if you want to practically see it happening, you can see it like that. Okay, so let this be the acceleration. Assume the angle between them is theta. Now velocity and acceleration are along different lines. What we can do is, we can split this acceleration into two components. We can take one of its components parallel to velocity. Okay, listen to this carefully. This is A parallel. Basically, A parallel is the component of acceleration along velocity. Okay, and you can take another component also in the other direction, in the perpendicular direction, like this. Now clearly, this component of acceleration is perpendicular to velocity. Component of acceleration perpendicular to velocity. Okay. Now, you all tell me, what will happen to the object if only this was there? Only this means only parallel acceleration was there. Okay, forget, ignore the upper diagram, consider only this. Velocity is to the right, parallel acceleration is also to the right. What will happen to the object? Will it deviate? Will it deviate from the line on which it was traveling?
No, sir.
It will not. Okay, direction won't change, but speed will change. So what we can say is that the parallel component of acceleration changes speed. Speed means magnitude of velocity. Okay. And that other component of acceleration that is there, perpendicular component, this is the one that actually changes direction. It does not interfere with speed of the object. You apply force perpendicular to velocity, speed won't change. Only direction will change. Okay. Now, as I said, this is an idea, and how this is important is, if you want to imagine how an object moves, when you know its velocity and acceleration, this will be helpful. See if acceleration and velocity are in the same direction. How to do that? You know how to check the angle made by the vectors, no? Velocity vector, get its angle. Acceleration vector, get its angle. If the angles are different, they are in different directions. If angles are same, they are in the same direction. So if acceleration and velocity are not along the same line, they don't make the same angle with the x-axis, that means they are in different directions, then you can say, like, then you can visualize what happens. You split acceleration into two components, one along velocity, one perpendicular to velocity. The one along velocity makes it go faster or slower. Okay. In this case, in this particular case, we see that A parallel is in the same direction as velocity. So it goes faster. Due to A parallel, it goes faster. And we see that A perpendicular is upward. So as a result of this acceleration, the object will actually move this way. Its speed will be increasing due to A parallel. and its direction changes upwards or it turns upwards due to that A perpendicular, because that is upwards. Okay. So these two components of acceleration help you visualize what is going to happen to the object. And a very good example of this is motion under gravity in 2 dimensions, which is what some of you may have learnt as projectile motion in 2 dimensions. Okay, I'll just take 2 more minutes. We'll close this session. Suppose there is a ball. That gray line is the ground, okay, horizontal. Let's say the ball is projected like this with some initial velocity. From your everyday knowledge, you tell me, Pawan, what will happen to this ball? Ball తీసుకొని ఇట్లా ఒక యాంగిల్లో ప్రొజెక్ట్ చేస్తే ఏమవుతుంది?
సార్ హెచ్ మ్యాక్స్ వరకు వెళ్ళి మళ్ళీ ఫ్లోర్ గ్రౌండ్కి వస్తుంది.
So you're only
అంటే
saying it
projectile
will rise up
motion
and fall down.
ప్రొజెక్టైల్ మోషన్ లో హెచ్ మ్యాక్స్ వెళ్ళి
What kind of a path will it follow? Straight line or a curved
నో
path?
సార్ కర్వ్డ్ పాత్.
Curved path, right? So we know from everyday experience, if you watch cricket or any sport, or if you have ever played with a ball also, you would know that it will follow a trajectory somewhat like this. Okay. Even if you had watched any cartoons and all, you may have seen this Angry Birds if you played. In fact, in cartoons, it is more interesting. They play sound also in the background. When it is going up, you'll see you'll get one sound. When it is coming down, you'll get when it goes up, now the sound will decrease. When it comes down, the sound will increase. Okay, you all tell me, if you know, you tell me. As the ball rises up, what do you think happens to its speed? Will its speed increase, decrease, or remain the same during upward motion? That means during ascent. What happens to the speed of the ball? If you know, you can tell, otherwise leave it. Do you think it will speed up? Like, let's say initial speed with which it was thrown is 20 meters per second. So as it moves up, what do you think will happen to its speed?
స్పీడ్ డిక్రీజ్ అవుతుంది.
Correct. How did you say that? Did you observe that anywhere?
నో సార్ అంటే యూ కాస్ థీటా అని అలా ఎక్స్ప్లెయిన్ చేశారు.
Okay, you know the calculations. Fine, fine. Anybody else? Or can you justify why the speed decreases? Okay, listen. It is true that the speed decreases during ascent. As the ball goes up, the speed decreases. Why it happens, you understand. Yusuf is saying it slows down because of air resistance, friction due to air, and gravity. Correct. And fine, we are not considering air resistance yet. Those viscous forces and all we are not considering. Due to gravity also it slows down. Okay. Now let's see why it happens. Now its velocity, as you can see, is in this direction. And we all know that acceleration due to gravity is always downward. Okay. So this becomes a case where acceleration and velocity are not along the same line. Right? So this is one application of motion in a plane. And you have this in your syllabus also. Acceleration due to gravity is in the downward direction. Velocity is not upward. It's not downward also. It's tilted at some random angle. So acceleration and velocity are not exactly in the same direction. They're not exactly opposite also. In such cases, what you should do is split the acceleration into components along the line of velocity and perpendicular to line of velocity. Listen, all of you, this kind of visualization will make physics questions interesting. Okay, and as I said, imagining what happens in a situation is very important. Okay, so this is the acceleration vector that we have. You can split it into two components. Now you can take component in any direction, not only in the x and y directions. Okay, so what I'm telling you to do now is take one component along the line along which velocity is acting and take one component perpendicular to the line of velocity. Okay, so the component along the line of velocity would be like this. And the component perpendicular to the line of velocity is like this. So the green one is A parallel, the component of acceleration along the line of velocity. and the orange one is a perpendicular component of acceleration perpendicular to velocity. Now see what is happening here. The parallel acceleration is opposite to velocity. And when acceleration is opposite to velocity, the object slows down. That is why during ascent, the speed of the object decreases. Okay, it's that gravity component pulling it back, okay, which decreases its speed. And see, the object doesn't follow a straight line like this. The object turns to the right side. What makes it turn is this perpendicular component, as you can see here. Perpendicular component is acting this way, so it will make the object turn that way. Okay, so this is what I was telling you a little while ago. A parallel changes the speed. It can make it go faster or slower, depending on whether it's acting in the same direction or opposite direction. Okay, the perpendicular component of acceleration changes direction. In fact, there are names given to these also. A parallel is called tangential acceleration. Tangential acceleration, and a perpendicular is called radial acceleration. Okay, the just a direction perpendicular to velocity, we call it as the radial direction. We'll discuss more about this in the next class. Okay, but just remember, to visualize motion in a plane properly, you visualize the velocity vector and then you visualize the acceleration vector, split the acceleration into components. In which direction should you take the components? One along the line of velocity and one perpendicular to the line of velocity. Once you do that, you'll be able to comment whether the object speed is going to increase or decrease. If that parallel acceleration is opposite to velocity, like what you see here, speed is going to decrease. Had it been in the same direction, see, during descent, when falling down, no, the speed will increase. Why? Because when falling down, the velocity will be like this. And the acceleration due to gravity, it's always downwards, we know that. If acceleration due to gravity is downwards, split it into components, as I said, one component along the line of velocity, you will see that it is in the same direction as velocity when it is coming down. And because it's in the same direction, it becomes faster. Okay. And that perpendicular component, if you take, it will be like this. And because the perpendicular component still exists, the velocity will keep on rotating. Okay. That's why the path is a curve. The velocity will never be in the same direction, will never continue to be in the same direction. So you won't see a straight line path anywhere. It is always a curve. Okay. So this is a perpendicular acceleration perpendicular to velocity. So during ascent, okay, during ascent, the speed decreases, and during descent, the speed increases. So needless to say, you can be sure that at the topmost point, the speed is minimum. Why? Because till then the speed decreased, after that it increases, means at that point it should be minimum. Okay. So this is where the object will be moving the slowest. Okay. Anyway, we'll discuss all this in the next class. Motion under gravity in 2 dimensions. Okay. Fine. So today we discussed how to, a little bit more about how to describe motion in a plane. We first saw that x component of velocity changes the x component of position, y component changes y component. Similarly with acceleration also, x component of acceleration changes x component of velocity, y component of acceleration changes y component of velocity. So if you want to tell what happens along the x-axis, take x components. If you want to tell what happens along the y-axis, take y components. We did some problems based on that. We calculated speed, angles made by the vectors. Then we moved on to the visualization part, how to imagine motion in a plane, okay, based on the directions of velocity and acceleration. That is what we have briefly discussed about. So we'll apply all this in a real life situation, projectile motion in 2 dimensions. Okay, that is what will be the topic for the next class. Okay, thank you all. And make sure you do all the worksheets. Today also I had sent one. Tomorrow also you'll get one. Solve the worksheets thoroughly. There are very few questions only, but you need to properly visualize and then answer those questions. Okay. Thank you all. We'll continue on Friday.
Thank you, sir.
Thank you, sir.